When push cutting, it's always essential that the right hand does all the controlling work, the leverage, the pushing, the twisting, the swinging. The left hand does none of those. What the left hand does is it adds weight to the front of the tool. That's essential in all cuts. And then it also needs to position the tool for the start of a cut. That's very difficult to do from the back. So let's show you how to position the tool with the left for whether I'm doing a sharp entry cut or doing a soft entry cut. So my left hand helped for both the sharp entry cut and the soft entry cut, because it's able to position the tool right where the line is if that's where I'm wanting to start. If I try and position the tool on the second line to the left with my right, it's very hard to get there without using my left to place it there. So it's essential for all cuts that your left positions for the start of the cut. There are several things the left hand mustn't do. It's not here to twist the tool at all. It's simply holding it, and if I need to twist it, the left hand follows. If I'm creating a swing, the left hand follows. There are no fulcruming. There's never a time when I fulcrum on my thumb or fulcrum on my palm. And I rarely grip overhand for most curved cuts because it prevents the tool from swinging. So most of the time I'm pinching and letting it slide forwards. It's also essential that the left hand doesn't add any weight to the bevel or push the bevel off the cut. So I'm going to do a cut around the outside, adding more and more weight to the bevel with my left hand, and you'll see the cut becomes defective. I'm then going to show you the opposite and use my left hand to destroy the cut by pushing the bevel off. And both of them are very ineffective, destroy the cut. Then I'm going to do the cut correctly by letting my left hand just add weight and allow the gouge to slide on its own accord as I push, swing, and rotate with my right. So as I did the series of cuts around the outside, you could see I was over rubbing the bevel, burnishing, marking the wood, and getting bounce. So I was losing control of the tool. And then I fixed it. Then I went round again using my thumb to push the tool around so there was no bevel contact. You saw it create a lot of ridges. Then I went back and fixed it, but right at the end of the cut, you saw the tool jump off the cut because I didn't use my left hand to slow it down. And on the very last cut, I cut it again using my left hand as a brake to control the end of the cut so that I didn't lunge through and I was able to cut the fibers off the end very clean. So that's the secret to the left hand, is not controlling the tool in any way at all, just simply adding weight, position, breaking at the end, and preventing skid for certain sharp entry cuts as well. When we're doing a sharp entry cut with a gouge or a skew, there's a potential for it to skid sideways on side grain, either the side grain on the face of a bowl or the side grain on a spindle. Because we don't usually do sharp entry cuts into end grain, that's almost irrelevant. And the tools that want to skid are skews and gouges. And that'll happen anytime where we get one of the setups wrong, or we don't use our left hand as somewhat of an assistant to help prevent those skids. So I'm going to show skidding on both and show how the left hand can help to prevent it, but it won't make up for bad technique. These are the 4 tools that do sharp entry cuts for coves and for V's. The bowl gouge for hollowing out a bowl has a potential for skidding at that stage. Spindle gouge for doing coves. A skew chisel because it does V's. And on the 4th is a vortex tool. This is a point vortex tool, and this is the one that is least likely to skid on entry. It's the one that penetrates the surface straight away. There's no additional edges to catch, and therefore is the one that will make that slicing in action without the potential to go sideways. I'm going to form a cove to the right here. I'm going to do the technique correctly using my left hand as an assistant to the start of the cut, and then I'm going to do the same, but not using my left. You'll see the problems I can end up with the tool wanting to skid left or right depending on the direction it's cutting into the wood. The tool never skidded sideways on either side. I was using my left thumb on the tool rest to pinch against my fingers and down. That downward pressure on the tool rest prevents the tool from going sideways. Now obviously if I use very bad technique and have the flute way too open, my left thumb won't be enough. But I don't want my left thumb on top of the tool, actually physically want it on the tool rest, then I pinch it. That prevents the skid, as long as the technique is correct. Now I can still skid sideways even if the technique is correct, because we have to go in with the flute a little bit open. So if I do that, you'll see the tool wants to go sideways. It always goes towards the bevel. Let's go in the other direction. You'll see again, wants to go sideways. So what I'm doing with my left thumb is I'm just doing the initial entry, is I'm preventing it from going sideways. So let's get a little bit of space made, and then I'll demonstrate the skid and then show you how to fix it. As you can see, I did originally mark out the cove to be the same size as the one to the right, but I made some errors because I wasn't supporting the tool enough on entry, and therefore by skidding sideways to fix those errors, I had to reform the cove. So keeping in mind, thumb on the tool rest, fingers in front, I'm pinching and holding it down, and then I just swing it round, same. Although my thumb is not directly behind here, my hand is braced against the tool rest, and that gives that extra additional support as I start the entry cut. Once I'm in the cut, my left hand is no longer needed to be there. In fact, it shouldn't be there. I must slide it back, allowing the tool to slide on its bevel without interfering with the cut. There is no area in this cut where I ever use my thumb to push or pull the tool. It's just an assistance at the start, slide back at the end. So what actually creates the catch? Why does it skid sideways? And the reason for this is that when we cut above the very center of the gouge, it's actually cutting end grain. And there it is. You can hear it cutting the end grain, and you can see it going sideways. When we've got the tool in the right position and supported, it's slicing with the nose. And when it's slicing with the nose, it's slicing through side grain, and the tool will stay still. Twist it open too much, which we sometimes need to do to get the initial start, then it will go sideways. So we've got to get a balance of the right height of the handle, thumb pinched, braced, and once into the cut, then I can release my left thumb away from the tool rest. So the grain on the one I created the coves on before was running in this direction. I've now got the grain running at 90 degrees. So this is our side grain. This is where I'm doing the entry cut, and that's where the potential for the gouge to skid sideways is very real. So I have to ensure that I enter correctly and I use my left hand as an assistant to make sure that it does go in and doesn't create the skid. So I'm going to do it in slow motion to show you what's happening. If I bring the tool in without support, the nose is biting, but it's biting a little bit above center. When I spin the piece, you'll see it go sideways. And if I was going in the other direction, which is not a common cut in bowl turning, you'll see it would actually just skid the other way. So what my left thumb is going to do, it's going to go behind the tool, actually on the tool rest. I'm going to pinch it with my fingers. I'm holding both down and in location. I'm a little bit close here with my tool rest. I'm going to move back just a fraction. I don't want the base of the bevel touching the tool rest. I need the bar to be touching the tool rest. This is going to allow me to do a sharp entry. But before I can do a sharp entry, I've got to create some space. So I'm going to create a little bit of space first and then show you as I get further and further around, the tool wants to skid. So you could see on certain cuts, I went in clean, no skid sideways, and then on the other cuts, it was skidding sideways constantly. The main difference between those two was when it didn't skid, I had my thumb on a tool rest and pinched it with my fingers, adding both weight to the front and preventing it from skidding sideways. Once I remove my thumb, it's much more likely to skid sideways because now it has nothing to support it behind. Now once the bevel is in the cut, then it can't skid sideways. So we've just got to initially get the bite, get the nose of the gouge in, then we must slide our left hand back so that the tool can create its swing or its straight cut, whichever it may be.